We went to the and you're telling us to check? I heard he said he has to check out, but then he said that because they want
Why do we need
What we have to say is that there are times like these where friends have common traits like sports, but they're not able to play with each other because someone has to, like, for example, this situation. So we have created a pad that can allow the visual player to play above no problem.
Otherwise it looks brown.
This might move forward, so they can hold
When the final prototype image comes, that we should point up to this is the ideas, this is where the muscles are, the vibrating moves are, this is our microphone, this is our lipo. Minor techniques that we planned it out to change it last minute.
I've seen the video.
Are you nervous? Just it's your parents. It's your parents. Just trust me.
You should go to Anu's lab. It's very similar.
Okay, welcome everyone. How are you guys doing? Good.
very well.
Okay, some more folks are coming, so they'll be coming in the next couple of minutes. Thank you very much. However, I'm just going to reduce the volume of this thing. Yeah, just reduce the volume a little bit. There, thanks. However, one of the exercises that we did during this week was that all your young ones, or all the makers over here, had actually designed some name tags for themselves on the laser card. You guys remember this?
Yeah.
This was all like day, what was it?
The first day.
Day one. But we didn't give it to you. So we have it now. But however, we just wanted to have a little bit of fun and rather give it to your parents and your other people that's here in the audience. So what we'll do is, while we're waiting around for the next 5-10 minutes, I'm going to pass on these kids, but to the adults in the room. And you guys, whoever name is on it, can help them to assemble it. Does that sound good? Okay, let's give this a shot. Let's see if it works or doesn't work. Okay, so this is Dave. I'll pass it on. Anyone wants to take Dave's? I also have Manan.
Dave.
Manan's family? Perfect. You guys grab this. Okay.
Dave's family. You
Yeah.
have your families here? Okay.
Okay, fine. Then you can make it with your family. Sounds good. And I have, okay, they're all upside down, that's fine. You help me with this thing? It's upside down, that's fine. Sit down.
Where do your mom?
Sit down.
She's right there.
There you go. Shabu.
You have to accept.
Shayan. Shayan?
Shayan's parents are
Ashar,
coming.
parents are coming with this.
Okay, okay.
Do I hold my parents in that way?
Yeah, you can, if you like. Nirav? Okay, okay. Okay, actually this is for your team. Nirvan.
But I can take
This one is Anya and
It might fall off.
Yeah, put it here.
Is your mommy here? Okay, which team?
Yeah, I know.
वो print हो रहा है
Okay.
ये दो lights हैं
Okay.
Instruction, hold on. Let's not.
Okay, this one.
You're going to give instruction? Okay, thank you so much.
Are we allowed to break it so we can create it again?
We'll give you some instructions. Okay, some. Not all of them, but some of them.
I can't, no? I don't stand.
Everyone's got it?
Yeah. Can I
One wire.
Bulbs and one button. And then there's a magnet. Get the magnet.
Okay, once you got it, you can open up your brackets. And what you want to do next is, you want to first peel off the brown tape from the acrylic. Now this is the most annoying part of our lives at our makerspace, which is removing these stickers. So please go ahead and do it yourselves. It's extremely satisfying to remove the sticker. Once you do, it'll feel very good. It's the most annoying, but at the same time, it's the most satisfying feeling once you manage to remove the sticker. Please feel free to remove the sticker on both the sides.
सिद्धांत रखना है ना
नहीं Siddhant,
ये ऐसा नाम लिखा हुआ है ना
it's a name tag. It will light up.
Yeah, create, right?
Good. We have to roadmap to this.
Vaibhav, even the name has to be removed?
Yes, you can.
Just show the final version.
Yeah, basically remove it.
Okay.
That's all.
Yeah, you remove your, on both the sides, and it's all transparent, you remove it. See if that is a road format.
She's coming. Her mother is mother's.
On the pause, the ladies have been pause and negative. The ladies have pause and negative.
How many layers are there?
Okay, everyone's removed this really annoying sticker?
No, not yet, not yet.
Okay, good.
Starting.
Still struggling, that's okay.
He's not giving it to me also. See? But auntie got each and then you put it.
Okay, remove it from the other side. It's all a sticker.
I'll just start it for you. Why even trying?
I like you to know there's about a lot of stuff. Yes.
Okay. There's some in that.
I'm getting it. Okay.
Yes, I see some of them already removed. Well done. Was that extremely satisfying?
Yeah.
Nice. It's a little reward for everyone that came on time. They're removing the sticker part. Okay. How many of you are still struggling with the sticker? Just raise your hands so I know. Okay. Good. Once you manage to remove it, we will go to the next one.
Guys, shape. Yeah, drop your lamp.
There are two LEDs, one grass wire and one
It's lighting up because it's next to a metal coil battery. You drop the
Okay.
battery.
Everyone's got the sticker off?
ऐसे क्लिप लगाने हैं.
Can I get you guys back? Everyone's got the sticker? Okay, great. Can I get everyone's attention? Can I get everyone's attention?
Yes.
Okay, awesome. What we're going to be doing now is we're going to be making an extremely simple circuit. How many of you know how to make a circuit? Good. Then you guys will have a lot of fun. We're going to be making an extremely simple one today, where we're going to try and light up some of the LEDs. You guys see in your bag, you've got these things. These are called LEDs. Any of the adults know the full form of LED?
light emitting
Light
diode.
emitting diode.
Very good. Full points over there. Now, if you look at these light emitting diodes, come on in. And this one's called a
Battery.
point cell or battery. Yes. It's a battery. Yeah, point cell. Perfect. Now, if you look at your LED, it's got two legs on it, or two leads. One is long and one is short.
Yeah.
What's the long one? What's the short one?
Positive, negative.
Which one's positive?
Long one.
Very good. And the short one is?
Negative.
Very good. So what happens if you put the long one on the positive side of the battery and the short one on the negative side of the battery?
Yeah.
Oh, it lights up. Just like this. What happens if you invert that and put the short one on the positive side?
It'll not light.
Nothing happens. Boom, boom, boom. Okay. So now you guys get the concept of the circuit. What we have to do now is we're going to be assembling this little fun circuit where we have two lights and one battery. So we basically trying to light up two LEDs with one battery. Okay? So this is what we're going to do now. The first thing that I want you guys to do is to put your LED right there with the long lead, which is the positive one, on the flat surface, which is basically the one which is smooth, and one side is going to be the rougher one, right? You can feel that one side is rough, which is etched. So the edge surface is the back, that's where your negative side is,
The positive to it.
and plus, or the positive, is the smooth surface. So you want to just put your LED in with the positive side facing the smooth side.
Facing the smooth side.
Yeah.
That's right.
Put it on the back.
Yeah.
Positive is the long one. That leg needs to be on the smooth side. And so just like this, you take the LED, you open up the legs, and you take the plus, which is on the long one, and just sort of hang it in there. Just
It
like
has to
this.
go in.
Just like this. You see, I'm just hanging it in there. The plus is on the smooth side, or the long one. The short one is on the negative side, just like this. It's hanging in over there. Right?
Yeah.
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 Okay, all the makers, now you guys are M1 level makers. Okay, help them.
Mine is
Help everyone.
That is better.
Yeah? You guys can help them. Fellow, you want to go around and check? Hello, you can check. Just to make sure everyone's got this right. Yep. And you can do that for both the areas.
Yeah, that's correct.
And can you get all the students out? Are they done?
Negative on the top.
Wherever the negative leg is, you are.
Okay, so once you're done with this, what we need to do now, this is the fun part, we need to twist the legs. Oh, sorry. So, on your boards, on the acrylic piece, there are 2 points. One is this hole that you can see,
Yeah.
okay? And one is this notch. Can you see this little notch on the surface?
Yeah.
It's like, it looks like it's a mistake, but it's not.
Yeah.
Okay. That notch is where you want to bend the positive one, just like this on both the sides, and just sort of curl it down a little bit. So I'll do it over here. You see this? I'll pass this around. So this positive side is put over there and then bent around. You can pass it around for reference.
The positive goes to the hole.
Positive goes on the notch.
On the notch. On the notch.
Yeah, on the
Comes
notch.
around.
Okay.
So the logic is the side of the battery is positive and the back of the battery is negative. Okay, you'll understand that. Something is already blinking. Yes, almost. But first bend it.
Bend it.
So the negative one is on the rougher edge and you put that inside the hole and you bend it to the front side.
Yeah.
Got it?
That's what.
Okay.
What do you do?
Yeah.
Not getting even.
Anyone else wants to see it? Anyone else down? Good. Okay. Yeah. So the negative one goes into the hole and the positive one goes to the other side.
What do you do?
So what is coming out? What do we do with that?
Just hold
Yeah.
it. Hold it down.
Once you're done with this, just bend it away from it, away from the video. So you don't want to create no sharp surface, right? This is how it should look. The front side, which is the smooth side, should look something like this. The back side should look something like this.
वैसे ही लग रहा है क्या जैसे बोलने में?
Yeah, everyone's up?
The leg is a little bit down.
Okay.
Side आ रही है ना?
Some of you guys are already lighting up the LED. I can see you. Good.
दे दे बैठ
Hopefully, all of us
First
are
we
already
need
lighting it up.
this one.
Let's see what is it.
The wire will go inside.
Everyone got this? Yes?
Yeah.
Okay, then for the last step. Okay? You see the golden wire? That's
Abhi,
not
you
very
wanna
gold. But it's made out of brass. Brass is a what? It's a good conductor or a bad conductor?
Good.
Good conductor, very good. So we're going to take the brass, make it into a little U-turn. Make it into a little U-turn like this. And we're going to put it in where you put the negatives. So basically it's going to create a bridge from both these holes. So you have to stuff it in with the other lead. There's already a lead inside, you have to just stuff it in with that. Can I see the sample?
From the smooth side or from the... Now for the
From the nozzle.
no?
On the back side. Where is the sample?
LED is not it.
Just like this. You're basically stuffing it in along with the negatives. So basically it's creating a negative connection. Negative connection. Sounds like it's a step of the door. Let's see how many people actually get this right here. Just like this, on the negative side. It's a little experiment, honestly.
And the back again, it should be actually
Yeah.
here, you know.
Hold on. Some of you got this on the negative side. Okay. And then, once you're done with that,
Negative is the back.
just like this, basically put it in along with your negative leads. So it's basically going into the same hole as the negative leads or the short leads, just like a bridge. And again, you can bend it away. So you'll have to sort of push it in if it's not going in easily. Then you just push the brass wire around like so.
It's not touching.
Got it? Nice. Want to short it out to everyone? Just stand up and turn around. There we go, that's what we're getting to. You're getting there, you're getting there. Oh, some more blinking already. Okay, and as you can expect, the last part is to put the battery in. Okay, see if that works. You're going to feel a short second.
Hopefully your back, hopefully your thing doesn't explode.
The negative side should be touching the brass wire.
If you figure it out, go help somebody else. If you figure it out, just help the person next to you or behind you.
Wear it. Wear it on your t-shirt. No, just show it. Wear it.
Got it?
Be wear it.
Got it. Nice. Well done.
I got it. Yeah, it is used to electric components.
Awesome. Did everyone get it? Finally, you can put the little lanyard or the little tag and pin it on if you like.
Maybe paint it as a bridge.
They go on one side, like this past.
Anyone stuck? Everyone got it?
The leg doesn't have to go with the negative bar connects to it. And the positive goes on.
Are we all done? Can you clap for everyone?
Oh, my parents figured it out.
Okay, how did that feel?
Again, you fidget rates come up.
Did you enjoy that fun exercise?
Yes.
Nice. How did that feel to light up the LEDs? Let's ask the parents first, guys. All the makers, just 1 second. How did that feel? Did that feel fun? Nice. Good fun to make stuff, right? Did it feel frustrating at the beginning? Very good. Good. It was pretty quick. Taking out the sticker may be a little frustrating. Okay. So thank you guys once again for being here. I'm going to start now that everyone's assembled. This was just really me buying some time so that everyone comes out as well. So good, we did well. I think all of you guys got to make something and also experience the same feeling that what's been happening over here for the last 1 week. The last 1 week was truly amazing. And thank you for sending your better halves, I would say, all the young makers to us. It was super fun to work with each and every one of them. We went through a lot of stuff this week. And if this circuit was a little complex for you guys, these guys have been doing something quite a bit complex. Quite a few of them. I don't want to get into that. They'll talk about it. But the last week's been a lot of fun. Yes. Yeah, thank you.
So can I keep my video?
Yeah. Okay, guys. All the makers, can you stop working now? Laptops, phones. Thank you. Thank you. I know you guys are excited about your presentations. Okay, thanks. But let's take a look at what happened in the last week. Okay? So in the last week, a lot of stuff happened. This 1 week was intense, it was fun. We started by getting to know each other. This was day 1, when all of us came together for the first time. And we played a few exercises, we got together. Everyone's from different parts of the country, and that's the beautiful thing. How many cities is that? Okay, we'll check. But it was beautiful to have everyone joining us from all over, getting to know each other, getting to meet everyone for the first time. But now I can truly say that a lot of us are friends now. And then we discovered a bunch of skills. So we learned everything from soldering. Some of us smelled like chicken afterwards. How many of you smelled like chicken? Towards the end of it. 1, 2, maybe. That's good. That's part of it. That's the learning that you get when you end up burning your little finger once in a while. But we learned how to make these fun blinky badges. We also learned how to work with bigger machines inside the wood shop, like the sanding machine or the 3D printers and all the other tools where we spend time actually figuring out how to use them and also use them for our projects, and you will see that today. Once we're done discovering all these tools, a bunch of hand tools, power tools, different tools, we worked on some projects which you guys will get to see in some time. But we explored a lot. We actually spent a lot of time exploring these ideas. We spent time actually learning about what's going on, how to make them, what's happening. And we did a lot more exploring, as you can see. We were there for them whenever they needed us. All the mentors were there as support, but all the work's been done by each and every one of them. And yes, we had a lot of fun. How many of you had fun this week? Did you guys have fun this week?
Yes.
Can I hear it?
Yes.
Once again?
Yes.
Okay, but we had a lot of fun. I think we had a lot of fun as mentors as well, working with all of the amazing fun projects, to see all the energy and all the excitement in each and every one of them. When things worked and when things didn't work. We also had a lot of frustrating moments. Just like how maybe some of you felt while opening up the stickers, we felt much worse versions of that. When things did not work. And I think they will tell you the stories of how many times things actually don't work before they work. And we'll get to see some of those journeys today. We also had the board game night, and it was truly exciting to have some of the families also join us. It was so nice to have you guys here with us. But board games are fun, and plus it's a big part of the culture, because a lot of the folks over here also love designing new games. So it was really fun to have everyone over, play a lot of board games all night. We did the repair cafe yesterday, last night. I don't know, how many of you were here till like super late? We were here till like almost 9 p.m., 10 p.m. We were repairing a lot of things, and we'll try to fix a food processor as well. But we managed to do something with the TV, which was really cool. We managed to fix a cassette, Walkman from the 1980s. We managed to fix a lot of different things. A cycle, kettle, lamps, label maker. That was a good one. Oh yeah, super fun. So at the asylum, or Anmol has a fun saying that if something is broken, you can't break it anymore. So it's always fun to take it apart and see what's inside and give it a shot and try and fix it. And we really encourage that, and we enjoy doing it ourselves. And of course, we've got some amazing mentors. So before we begin, I'm going to also give a few shout outs. So Fennel, right there. Samir, alumni mentor. So special one to Samir because Samir was part of the program last year. He came here just like everyone, worked on his project, and now he's back again as an alumni mentor, spending time actually sharing and learning together, which is beautiful. So thank you for doing that. Thank you, Week. And of course, we have Annette, Rishi, Charan, managing all the work. We have Doc Show there. Anul here. Dolan, Rachel, and of course, Arjun, who is manning the cafe. Yes. So now, without further ado, what I will start doing is, I want you to hear from the teams, one team at a time, and see what these guys have done. Because they've done a lot of baking in the last week, and they have a lot of beautiful stories to share with you guys from what worked and what didn't, and how things went by. So first off, we're going to have Team Cohort. Why don't you guys take up the stage? Get the other mic. Yeah, the presentation's right there, so just press next. Go.
You got a short skin.
Oh, I've been stabbed by a batarang. I'm dying.
He needs urgent medical attention. Or maybe I can call a truck driver to transport the medicines. Hello?
Hello?
How long will it take you to transport medicines? This patient is in desperate need.
Around 2 to 3 business days.
We need it by the end of today.
That's not my fault. You live in the middle of nowhere. I can't transport it a day itself.
Oh no. Let me look around on the internet to see if there are any other alternatives. Oh, there's a drone space. Let me call them. Hello?
Hello.
How long will it take you to deliver medicines?
Where?
This patient is in desperate need.
Where do you live?
Literally in the middle of nowhere.
2 hours.
Okay. 2 hours later. He's cured! And this is a demonstration of our road. But Team Copper, also known as Team 20. My name is Nirvan Doshi.
My name is Abhay.
My name is Anya Gora.
Yeah, you can go next.
So, you know those huge lunches or dinners where you really want pizza, a burger, or maybe even chicken curry? Now imagine that, but your food are medicines, and your need for food is your family member dying and your local hospital that's up in the mountains just can't provide the medical care that they need. This is where we come in.
So our main goal and the main purpose of our project is to reduce the time taken for an essential good to travel from an urban area to around a rural, hilly region. The reason for this being is because around these areas there is normally large transportation can't come because it's normally underdeveloped, and also since it's on such a steep hill or mountain, they're not able to reach this kind of area.
So we have designed the quadcopter, which can transport medicines in tested situations at a faster rate, where roads and transportation isn't really accessible. So I'll just be explaining how we made our drone. So as you can see here, there are two simple buttons which are connected to an ESP32, which is a microcontroller. We use the protocol ESP now to connect one ESP32 on the ground to the ESP32 mounted on the drone. This ESP32 is then connected to a servo motor, which flips a box. But how exactly does this motor work?
So think of the ESP32s as two brains, where the first ESP32, upon the command of pressing the button, sends a message to the other ESP32, which transfers that message to the servo motor. The servo motor is like a muscle which operates a flap moving up and down the medicines. So, but why do we need the flap? So, the one thing that our drone can do, which no other anything in the industry can do yet, is we don't need to land. Our medicines are delivered in mid-air, therefore we can deliver medicines anywhere to wind places and really steep places, whereas other drones in this industry will need to land and then deliver the medicines.
And yeah, that's our project. It simplifies transportation in these EV regions. So now we'll be talking about the challenges we faced.
So one of the biggest challenges we faced is firstly the product design aspect of this project. So while designing the box and how to exactly mount it on top of the drone or onto the drone, we had to make over several prototypes to finally get a final box design to actually mount on top of the drone. And learning new apps was also a little hard because we had to adapt to them. And we had to laser cut our box 3 times to finally get it right.
Another issue we faced was the power supply. As you may know, Goa is currently in the monsoon season, and due to that there were power shortages. To solve this problem, we used power banks, and we also used a lipo battery, which you can see right over here. This simplified our power. But these sound really heavy, so how do we do that?
Well, if you see our drone, it's quite small as it is. So when we tested our initial product, we realized it can only carry 80 grams. Now how do you fit a payload, plus with all the technology required to support it, which is a flap and everything, in just 80 grams? This is when we came up with the idea, my teammate, to switch from a power bank to a lipo battery. Now a lipo battery, though it can't provide as much power, it's almost 30 grams lighter, which provided just enough of what we needed to make it fly. We couldn't make it fly, unfortunately, in the demonstration due to safety reasons indoors.
Yeah, we will be flying it after this program. And yeah, this is basically a bunch of pictures of us.
So this is like a photo gallery in our slide, and this is kind of the whole process we went through, from the prototyping to the coding to the 7 box designs. But yeah, and this is like the digital design of the box. Then
yeah, so this is basically the mechanism which is used on the motor in which this flips. And yeah, this was our first time actually testing it, and we had to refine our product in multiple ways. And as Anya mentioned, we had to change the box at least 7 times to support the weight restrictions, and we also switched from a USB to a lipo battery.
Alright, that's it. Thank you so much. Special credits for
Yeah, any questions for the team? Did you guys want to fly the drone inside? Okay, outside. Okay, so later. Okay, please go out to test the drone. No indoor drone flying. Okay, that's fine. Any questions for the team?
Any questions, any comments?
yes.
Like you said that instead of landing and giving the medicines, they'll drop the medicines. What if the person doesn't catch the medicine?
That's a great point.
We can put it on really soft surface. You get to choose where.
And also it's covered in packaging.
So the medicine just dropped down to the middle of nowhere, but what if it landed and
We're gonna guide it so that it drops in the place we want it
That's a part of the controller. Yeah, there's a controller which we have to ensure that it drops in a specific drop.
No more questions from you guys.
Oh, yeah?
Yeah. What if the medicine means more than 100 grams?
Yeah, that is.
This is our first concept. See, if our real drone we're making is not this small. So this is just the first concept drone to test if our idea works, and then later,
Yeah.
if this was a real project, we'd expand it.
Adding,
Because this is just a prototype.
adding on to that, a final prototype would be able to transport.
Would be able to transport goods which weigh a lot more than 100 grams. It's just we didn't have access to like massive drones, and due to that, the maximum capacity for our first prototype is under 80 grams.
We just wanted to see if our concept works.
If we can take this project ahead, then we will definitely use a bigger drone that can go more.
Okay. Any other questions?
Yes.
Are you thinking of putting a camera to ensure the medicines are
We have a
Yeah, we have a
Camera.
camera.
Sorry, wait. It's right over here. I don't know if you can see it.
But yeah, that helps with navigation.
Any other questions?
Thank you.
Awesome.
Terranex, are you guys here? Okay, whoever is handling the presentation can be here. Who's handling the presentation?
Yeah. Come.
Top is here.
Sorry, so you come here now, Shreya. We're taking video. Thank you so much. Please lift your
Hello everyone, we are Team Terranex. So let me begin. India, a country with a population of over 1.46 billion people, in which there are over 140 million farmers that represent over 9.58% of the country's population. Now these statistics may be really confusing, but let's get to the point. These farmers face numerous issues, such as not being able to invest enough money in their capital and the extensively long time that it takes to check and analyze an entire field. Imagine going around 1.5 hectares of land just to check and analyze soil moisture. Of course, that sounds really tiring for someone like you and me who finds it a difficult task to walk from your bedroom to the kitchen to grab a cup of coffee in the morning. But it's not just you all. Even farmers get tired, working day and night endlessly. Farmer suicides also account for 11.2% of all suicides in India, which means a farmer is more likely to suicide than the average person. And this is basically because the farmers are not able to earn enough money from their land.
And that's where Terranex comes in. But before I tell you about our solution, let's see how others have solved that problem. So, many modern solutions depend on high-end technology like drone surveillance, agriculture systems, and huge platforms and databases, which are not really accessible to modern-day rural farmers. That's why we created Terranex. Terranex takes a different path, focusing on simplicity, affordability, and soil monitoring that any farmer can access, and water their plants accordingly.
Now,
we are going to get into a lot of technicality. So now we're going to get into a lot of technicality. You don't need to understand it all, but just get a broad idea. So we have a lot of mechanical stuff here, as you can see, a lot of aluminum extrusions that are connected together, and that forms our chassis, which is the rectangle you see over here. That is very important because it allows all the parts to come together. That is what is forming our actuator, allowing our actuator to move up and down and check the soil moisture in the soil. The actuator works on a thread which moves a brass nut up and down by screwing it. That screw spins using the NEMA 23 motor.
Okay, so now for our software aspect, we are using a Raspberry Pi on board, which is basically a small computer which is very powerful, and there we have coded our custom system in which you can draw a path and the robot will autonomously follow it and periodically stop in order to take soil moisture tests. Then all of these tests come together and form a heat map where we can decide where there is soil moisture and where it's a bit dry or wet. Based on that, farmers can strategically decide where to grow past, what kind of plants they can grow, and how to increase the net yield. We also use a system called UNO, where it is not you only live once, it is you only look once in this case. And here we have a camera on board, which is going to use this AI model to detect contamination in soil as well as alert the farmer if there is any waste.
So basically, this is some pictures that we took along our journey. So first here we have our initial model that we made, our CAD model, which is basically what we thought it was going to look like without all the circuit and stuff. Here is an image of us assembling the chassis, where we use aluminum extrusions, and at the corners we use bolts added together. In the corner there, we have an image of our wheels, which was our original prototype wheels that we used and 3D printed, but we found out the internal structure of them was too weak. So we have to 3D print these wheels, which you can see here. And there is our actuator. We had some trouble with the actuator because we have to reassemble it, and because it wasn't working correctly and not going up and down. And here we have a circuit. When we were building the circuit, we accidentally soldered the wires to the wrong pins, which caused us to have to resolder it and do it again to the correct pins.
And that even caused the short circuit over here, and that was a spark.
Yeah, which caused our motor to fry.
Yeah.
So
Now this is our project.
So now we have a demo here.
This is like the app. So this is the dashboard, and as you can see right now it's just calculating the soil moisture.
So we have a light plate here which is pointed directly at a sample of soil, and now we will start a scan. So this is a stationary scan. In actual lighting we have more space, it will actually drive to the spots. So this is assuming that this is the spot is going to scan.
So this is the soil right on the screen.
So now the actuator is moving down with the soil moisture sensor to penetrate through the soil in order to get a reading. The sound is normal here.
So now as you can see,
So
now
it's gone down.
stuck.
Yeah.
You can see over here the soil moisture. The soil moisture sensor is inside the soil, which now it's detecting the soil moisture.
And now after doing that, it will come back up.
The reason it's making a bit of this noise is one of the bolts.
Yeah.
So this is a video of our project outside.
This was when we were actually testing it inside the grass to check if the actuator is actually able to move the soil down.
And the soil moisture will penetrate the ground or bend and snap.
So luckily it did not bend and snap. Actually it did bend and snap. But it got snap. So as you can see, this is the soil moisture which is penetrating.
So yeah, this is our project, TerraNet. Thank you.
Any questions from the team?
Yeah.
I have a question.
Yes.
Why go on the ground and not do the drone? Is there a reason? Is there affordability?
Because if you're example on a drone and we can't exactly like check the soil moisture because it's high in the ground. If the robots on the ground.
have to land down onto the ground to check the soil moisture. You can't check from the sky, and that happening every single meter of the hectare land is really not bad.
Yeah.
So will you be able to?
Yes.
Yeah, that is why our wheels grow. We had to split.
That's why our wheels grow.
Very
Because it's totally enough.
Plus these motors are also pretty powerful, so it's not that it won't really go up. Like it can handle a certain level of terrain.
Well done.
Which is what found.
Yes, she has a question.
Quick question, is it only to check moisture or also like pesticides?
So right now the prototype only checks for soil moisture.
But if
So
we
that can
have-
explain the farmer what type of crops to plant at what time.
But something like this can be used to
Yeah,
check
but it can have a
pesticides.
lot more sensors and has a lot more.
Yeah,
So
but like
just check the pesticide with the soil contamination Euro model in the camera. So we will get the contamination and we check for beans in there.
The question there, guys.
If you were going to keep the project together, where
We change anything.
sorry, if you were going to keep the project together, is there anything that you change or do differently?
Yeah, we would definitely first thing we would focus a lot more on it because we realized that was a major issue for our project.
And we will find a way to keep these wires a bit neat right now. That we go
right now they're like a huge mess. Yes.
Even for us,
to debug it,
It's
basically like when something goes wrong and if you try to fix it, it's quite hard to do that.
Yeah.
Like soldering these numerous wires over here was a major issue. And that's what caused the problem.
Thank you.
With the team.
One more question. Is there a similar product like this out there that you know? How did the idea come about?
There probably be rovers that go on farmland, but I'm not sure if there are existing rovers that check soil moisture and generate a heat map, which is immediately sent to the farmer. So it's real-time updates. So the farmer doesn't have to sit and wait for the bot to do its
To
job.
finish the entire
Because
1.5 hectare
even with a robot,
and then the farmer gets the readings. In real time we'll know, so then the farmer can kind of plan. Yes.
because even a robot, no matter how fast it is, covering 1.5 hectares, like a certain pattern which is set by the farmer, will of course take some time. So rather than waiting for the readings, you get them instantly. And in a visual form. Can we click the picture?
He's gone to wash his hands, so later with the time. We have enough photos for everyone. Okay, thanks guys. That was awesome. As you noticed, okay, can we start moving carefully? Yeah, as we noticed, we've had it's been on and off. There's something with the frequency there. But yeah, we've got two youngest people in the room, also part of this team. They're generally less than average. We started 13, but we took both of them in because we thought they were very smart and very enthusiastic, and they were pretty much all of that during the week. So hopefully that was fun. Okay, awesome. Next up, we've got the Sonic back, guys.
But once again, all this has been done by them in like a week's time. So what you guys are seeing over here, this is them actually making this happen in just about 4 days, because before that was training. So big kudos to all of them. And at the asylum, just like these guys know, Murphy's Law. You guys know Murphy's Law here? Anyone wants to explain to all the adults in the room what Murphy's Law is?
Anything that can and will go wrong, will go wrong.
That's right. Anything that can and will go wrong, will go wrong. That's the only mantra that we believe in. Okay, back to these guys. Off we go, Sonic Bat. Tell us about your story.
We're going to start with a small skit. Hey bro, guess what? My team won 124 runs in blind cricket.
Oh well, we as well won by like 150 runs yesterday.
It's so sad to think that both of us have a huge passion for sports and are like really close friends, but we can't play with each other.
And why is that?
Well, it's kind of obvious. Our playing styles are so much more different and our teammates won't be able to like coordinate with each other.
Well, not anymore.
Throughout this journey of the asylum, we have designed a bat that can increase the inclusivity of cricket, where the visually impaired can play with the sighted players. I'm Skancha Trivedi, that's Manan Parekh, and that's Dev Javedi. And we are Team 17 representing the Sonic Bat.
Our main issue is that situations like these, where very good friends who have disabilities and people who don't have disabilities can't interact with each other and share their passions. We are working towards making cricket more inclusive sport.
So, we never had met each other before the pre-residency, but when we met, we came to know about our common interest, which was well sports. So we decided to do something about it and make our final project something related to it. So we thought that we might as well do something in cricket, but we should also help the visually impaired people. So we came up with a bat that can help visually impaired people play cricket with everyone else.
The challenges. It's the most frustrating part of the trip. So I was working on the hardware and the soldering part of my team, and the most frustrating things I found is that obviously I burnt myself with the solder, I cut myself with the saw, and of course I was reminded by of course our alumni mentor Subir. I was the most injured over here.
Well, the coding was the most annoying part for me, cause like I had to almost go through like 7-8 codes to get one that finally works. And well, we had to change the hardware again and again, so the code kept on updating. But like, I'm finally happy and relieved that this one works and we have a working model now.
CAD, which is computer-aided design, is what I did in the group. I created this stand that will go with the power bank and the microcontroller, which is the ESP32. This was very difficult, but with the help of one tool, so I finally 3D printed it.
So basically how our project works is we have a sensor in front of a bat over here, and that is connected, which is known as a LiDAR sensor. That sensor is connected to the microcontroller, which is placed on the batsman's neck. We have used the ESP32, and now to the ESP32 we have connected 3 vibration motors. So these vibration motors will go on each side of the batsman's neck to alert him when the ball is coming. So basically, once the ball reaches a certain distance from the LiDAR sensor, these motors start buzzing and basically the batsman knows when to swing. And to this ESP32, we have used both LiPo battery and a rechargeable power bank.
Should we show them a demo? So what's happening right now is that the LiDAR is sensing some distance from any random object and it's sending a signal to a microcontroller over here. that sends another signal to the vibrating motors. Depending whichever distance the object is coming from, that's where the vibrating motors vibrate from.
Put the mic in front of the vibrating motor. So like once this mic will come closer to the slider, the motors will start buzzing.
Nice, very nice.
The final prototype. Manan will explain where we use what sensors we are using over here.
These are the vibration motors that would connect to the back of the head, which will tell the backman when to swing, and these two are on the side of the neck, which will tell which direction in which to swing the back. This is the little battery which will power our microcontroller. This is the ESP32 which will control all of the things connected to it, and this is also the power bank which will also power the device.
This is a video which we had run a test on this outside actually.
So in this it's quite slow because I'm walking with the wall, but his eyes are closed. So
basically in this entire diagram which is over here, I was acting as the blind person and the vibrating motors were connected to my neck. So Dave was walking with like a ball, a rough ball, and then as he came close, the LiDAR sensed the motion, so it sent the vibrations and I knew when to swing the bat. And of course, throughout this entire journey which we had gone through, we had realized how many challenges and hardships the visually impaired have faced physically and mentally. And as we worked out throughout this project, we have become more empathetic towards them. And adding on, I'd like to give a special thanks to all of our lovely mentors who were with us throughout the journey. Without them, we would have never been there. So thank you so much. Can we please have a round of applause for them? Any questions?
if you take this forward, of course it'll be like a more innovative design. But right now, imagine if you actually play cricket. What if the ball hits the 3D printed part and it breaks?
Right now it's just a prototype. If we were to take this project to the next step, then we would definitely take your recommendation into account. Any other questions?
How do you know really which direction the ball is going in? Because there are so many different directions the ball could go in, right?
Exactly, so which is why we use the vibrating motors for that exact reason.
One on either side.
yeah, so basically the one on the left, if the ball is coming from the left direction, the one on the left will pass. So it's kind of like an approximate direction. We have not worked around every single angle yet.
You also had a question.
From a safety point of view, it's a great initiative. But let's say today, you do have a bouncer. And let's say by mistake, the ball comes over your head, which is above the distance of the bat, then it won't cover, I guess.
Not really, but if you're playing with this, I would really suggest to use a more lighter
and like I said before, this is just a prototype.
Since this is a prototype, but is it possible to kind of program the distance you would like a feedback on? Because individual players might prefer longer distance.
So for this, I think we have set some 1 or 2 meters, but if we want, we can say change it to 5 meters or even lower, half a meter or something.
Yeah. So the sensor that they are using is the same sensor that drones use nowadays to figure out the distance to the ground or the follow me command. So these are pretty amazing sensors. Right now, for the prototype, they just put one, but the concept was to put 3 of them, so you can monitor pretty much connectivity and the bigger.
Yeah.
Another question. The recommendation for phase 2 is you could actually program the ball
Yeah, that's actually what we had done before. Like we were supposed to like put the circuit inside the ball, but it didn't work out well for us, and we had to like switch the circuit 3 more times.
But you had 4 old days.
Alright, that's it. Thank you.
Good job, guys. Thank you. A lot of cricket-related questions. Nice. Great. Next up, we've got aero relief.
Second last team?
No, we've got 2 more after that.
Okay, 2 more.
We're halfway through. There are a total of 6 teams. Yeah, actually it's working, so.
That was Manan, you were really good. You were good. Even though you did change the lines, but it was fine.
Have you ever imagined the house which you've been living in for the past, let's say, 10 years just gone? Have you seen, can you imagine all the memories you made just lost? This is what most people experience when a flood occurs. Like, just imagine being just swept away by the ocean like a warm summer breeze.
Yeah, so like that. So, I'm sure most of you know about the incident that occurred in 2019 in Karnataka when we were faced with one of the most harshest monsoons that we've ever experienced. So the 2 main states that were affected by this were Maharashtra and Karnataka. And almost 200 people lost their lives, 40,000 homes were destroyed, and over 2,000 separate villages were destroyed because of this flood. And you know, the government couldn't really do much because of the inaccessibility. So we decided to take matters into our own hands, and then this is what we've come up with. Why don't you introduce what you do?
My name is Ari.
Mine is Vihan.
And our other mixer had to leave a bit early. So our hero in our project was basically like the severe flood impact, and basically like people who were being affected by floods. And then our mission is to basically like support people who have lost their homes and they cannot receive medication fast.
Yeah, so the most vulnerable areas that, that's what we want to target. So the main objective of this project was to design and develop a reliable unmanned aerial vehicle for emergency medicine deliveries to flood-affected areas. The challenges that we wish to address in this project was the lack of resources by using an unmanned vehicle was to reduce the risk for other people as well, and to improve technology for rapid medical supply.
So the transformation of our project was basically to like revolutionize medical access in flood-hit zones. Like even like a couple of days ago in Texas, there was a huge amount of flooding. So I think that our solution could have helped deliver medical supplies much quicker.
Okay, so this is just a prototype of our product. I want you to lift the box.
This is a prototype of our box system. So one of our main objectives was like reduce the weight of the actual mechanism, because our drone can only carry 30 grams, unlike theirs which can carry 80 grams. We're so unlucky. So then to save weight, we managed to use a 3 grams servo, a program microcontroller and use the same power supply as the drone.
Yeah, so we wanted to create the lightest drone possible so that we can carry a heavier payloads, we can have faster acceleration while moving through the air, and just overall better maneuverability. Because unlike the larger drones like, I don't know, theirs, they can't go through, pipes and sewers, and what if someone's stuck in a house and all the doors are shut and rubble everywhere? You can't really get through. But if there's like a PVC pipe or something, we can just fly through that, deliver the medical supplies and then get out. And this is all a very fast process that we can get out. So, yeah, this was the first iteration of the pick-up and drop mechanism that we've used. So we first initially used bolts to secure the motor to the door, but that didn't really work because it kept on breaking, and this is a 3D printed part, so it's a little not that stable, it's a little brittle. And this is the printer that we used right over there. That's me. I'm definitely not watching YouTube. And these were the main challenges that we faced while creating this. One was the drone size. You can see it's like extremely small. So flying it was quite difficult. We tested it outside, and it could only take up to 30 grams. Next was the battery power, because we needed a battery that could power and like make the drone move and go up and down like really fast. But it also had to be like really lightweight. And third was the coding problems that we had. Out of these 5 days, at least 3 or 4 were taken in getting this coding done. I mean, this was really hard. I had no experience. Arek had some experience, he was really helpful. Our other teammates, Samiksha. Yeah.
I worked on the CAD for 2 days. The first version using my initial mechanism did not work at all. So then we tried a new mechanism which is sort of inspired by the other teams, and we also have the unknowns have quite a bit in mechanism.
Yeah, all the mentors were really helpful in this process. Yeah, so this is kind of where we started. This was the original pick up and drop mechanism. It completely failed, we had to tape it up. This is just a little display of our failures. So project.
The drone just crashed.
Yeah, we just destroyed it.
Burnt out.
Yeah. So this is I don't know if we do it. Play all of them? I don't really think I want to play all of them.
What?
I just smacked into a wall.
Second one?
It's the same thing.
Fine.
Yeah, same thing.
And the center of mass was off. Third one. It went a little higher. Then just fell out the sky. We still do not know what happened.
And then Arek decided to fly this one into the forest for some reason.
It just fell.
Yeah. Yeah, and this is our final project. Yeah, why don't you do
So final project, as you can see, we use the same battery from the drone, and as you can see, the mechanism is now in the open position. But when I close it, when I power it up, hoping it works. It's all about. It is supposed to close it.
Yeah. Yeah, I think we get it. Yeah, it can be controlled by phone as well because the ESP32 is Wi-Fi. Yeah, that's it.
Example, you said you're on a flawless thing and you need supplies. How do you expect the correct supplies in such a light category?
This one is just a prototype of it. We are hoping to use a much bigger drone that this drone, this version cannot carry anything. Like literally,
And
plus this is 3D printed. We can use a
Yes.
different material.
Yes, but like in the start, you said you were going to make a bigger drone. But then also in the middle of the presentation, you said you wanted your drone small so it could go through pipes and sewers and all.
I said our drone was
at the start, our ideas were a bit too ambitious. We thought we'd try to 3D print a drone frame because that would do a fun thing. Then with this one, in the middle of the presentation, we said that we want it small. But we don't want it too small. I mean, come on. It can't happen. This size drone flying out. It's useless.
You made two prototypes, small and big. So we tried solve both.
We tried to, but then it doesn't happen.
Yeah. You mentioned that you could navigate through sewers unlike our drone. How exactly does the navigation system work since you don't have a camera installed? Are you planning to install that in future prototypes perhaps?
We are planning to install a camera and a GPS system in future prototypes. But for now, this is just a silly remote control. Now, we were just planning to like just test out our delivery.
Yeah, that was the main objective of this, not cameras.
Awesome, thanks guys. Two drone teams. I don't know, conflict, rivalry, I have no idea. Is that what it is? You guys can collaborate, you know that, right? To just make a bigger one. Yeah?
Let's see it.
Everyone can see this?
Yes.
In the rustic fields, where farmers lost toil, compost heaps do act as a thief of their time.
But lo and behold, the bio-barrel, converting rot into gold with haste, freeing hands, and most importantly, ensuring that all people can turn into lords of a land renewed. I'm Sana Dukya.
And I'm done.
And this is the bio-barrel, which is a smart composting bin that anyone can use.
So, did you know that more than 1/3 of what we throw away can be composted? And food waste creates methane. That is greenhouse gas that is 25 times more dangerous than carbon dioxide.
One bin in your backyard can keep 500 pounds of waste out of the landfills every single year. And so, our project is to ensure that, that people everywhere can now overcome the entry barriers to composting, and we can educate more people about recycling and using organic waste for good.
Not only that, but we also want to create compost as an efficient and marketable product that is reliable.
And most importantly, we want to incentivize composting so that you can have one in your own backyard.
So what are the limitations? Well, the commercial products on the internet don't always form true compost and usually lack the sufficient nutrients that plants require.
They're often infertile and they don't actually provide the rich compost you need. And more importantly, they're large, bulky, noisy, and it's an expensive cost to pay up front if you just want to start composting as a hobby or something to add a little bit of eco-friendly lifestyle.
Not to mention that their electricity use offsets the ecological gains.
But it's an overwhelming process. You might have a lot of questions. How can I be more ecological friendly? How can I be more green? Where do I start? I want to compost too. But this is how we simplify the process for you.
Don't worry, we got you.
So we present the bio-barrel, which is a smart composting management system which uses 4 different types of sensors to cover all the bases for your composting needs. Yeah. These are our three different iterations. We started pretty basic with simple wires and breadboards with our components, but we began evolving towards more efficient prototypes that can be inserted into any composting bin and provide reliable results to the web page that we've created.
But the road to success wasn't very smooth. We had numerous obstacles, not to mention physical obstacles of soldering and calibrating the pH sensor, and software obstacles of coding.
I'm pretty sure Karna and I spent more time calibrating the pH sensor than working on anything else in our project. So this is an example of what the web page will look like. As a user, you can log into the website and based on your readings, it could give you suggestions based on what you could do to improve your soil conditions or to improve the pH values. But going back to the complexity of composting, we also provide a basic guide on the need-to-know basics of composting. How do you start? Where do you put your bin? What should your first layer be? And what sort of stuff do you put in? What should you definitely not put in? And that's how we implement user-friendly technology for composting in everyday situation.
So what is our project description? Well, our bio barrels supplement to and add-on to existing bins that can be used to compost. And it has multiple sensors that read and give you active and dynamic suggestions.
So, unlike a composting bin that you have to buy, you can just add it on to any existing trash can you have with all your wet waste, and you can begin composting right now. So, this promotes and educates ecological work, and it most importantly incentivizes composting because it's such an easy process, and we're making it easier for you. So thank you so much to all our mentors for helping us with this.
So you made composting easier for people who won't get into a composting, which would normally be in an urban setting, right?
Yeah.
So what would they do with the compost?
So I'm sure that you could have a balcony or even plotted ponds in your home, and one way to make them more fertile and to ensure that you have more green around you, even in an urban setting, you can use compost, which is just made out of your own kitchen scraps and giving back to your own house. Oh, yeah, you could also sell it. Yeah.
You all said it's a smart composting bin, but it's not really what happened?
So it is smart because it takes sensor readings and gives you active suggestions as what to do to make sure that your plants get what they deserve.
So what all kind of sensors have you used in this?
We have gas sensors that detects ammonia and carbon dioxide. We have a pH sensor, a temperature sensor, and a soil moisture sensor.
This is like the thing, where exactly will this be? Like, will it be in the compost bin, outside of the compost bin there?
So it has to be inside the compost bin so the gas sensor and the temperature sensor get readings. But the soil moisture, as you can see, it has an extension, so it can be inserted directly into the compost, as well as the pH probe.
Yeah, but like if you said it's inside the compost bin, then wouldn't usually in compost bin there are worms and all, and many soil and all of that. What if it seeps through? I see there are holes and all in the sensors. What if the soil or something seeps through and it damages it?
Because we only have 7 days, we couldn't completely waterproof it, but in future iteration we definitely.
And we're going to create plugs for all the parts that are sticking out so that everything is completely sealed. And also, worms aren't necessarily present in every single compost bin. That's specific type of composting. So that can be implemented separately if you are looking towards vermicomposting.
So since using an ESP32 and it will be in a backyard, how will it connect to the home's Wi-Fi? Because most people don't have Wi-Fi in their backyard, right? Most people don't have big homes. But that's
Most
also
people don't have that. Got a valid question. Okay.
It could also be a balcony.
The ESP can also create its own cache network by itself.
Usually composting bins are also just sitting in the kitchen. They don't go in the backyard.
That's also true.
Anyone else? Or yeah.
Okay, good job, guys. Awesome. Last but not the least, we've got keyboardless. Right. Who's handling what?
So, imagine you get in an accident or you get injured and you can't use one of your arms. That takes away your ability to carry out daily tasks such as writing or typing on a keyboard. And in this tech-driven world, we know that using a keyboard is one of the most important things you need to do for writing an email, writing down notes on your laptop, or just searching quickly on Google. So we got this problem and thought of a solution, which is the keyboardless. It's an attachment that you can place on any glove, and it just makes typing easier for paraplegic people and people who have injured their arms. But as we were going through the process of creating our project, we realized that this not only helps people who have injured an arm or can use only one, but also makes typing easier for almost all people, and it makes typing more efficient, and you can do it from anywhere you want to, so searching for a laptop and a
So, of course, there are many different components, and in this there are two aspects. There is the hardware and the software. So, the hardware we used, it was minimal, but it was necessary and essential to our vision. So, we used the Adafruit Flora to handle communications with our main computer and to take the readings from the sensors that we have used. Coming to the sensors that we have used are piezoelectric discs. So these are small discs that take vibrations from tapping and transmit it back to the computer. And we have resistors to ensure that the signal reaches the computer unfiltered. And we have a screen to show the actual letters being typed. Yeah, so this is the hardware that we used, and there were actually quite a few problems that we faced in this section. We had to resolder our components multiple times, as Sanant will tell you. If you can see here, these piezos, these were not exactly what we had at the start. The resistors were connected externally, but Fennel sir told us that it would be better to be directly on the piezo. And connections, I mean, connecting all these wires, especially all of the ground wires into the pads, that was quite difficult, but hey, we were able to do it, and yeah, we're just really relieved and happy that we were able to. And now over to Sham for the software.
So yeah, so I'm going to be talking about something which everyone definitely understands. But for the software, we've set up, I'm going to talk about three major points of it, which is one, so when I tap, for example, Siddharth taps on his hand right now, we have a screen, it's not very easy to see, so like later on you guys can come and check it out. But once you tap with the finger, the output will automatically get displayed over here. So for that, we just use the sensor and take in the value for the sensor, and if it's high enough, we've taken an output over there. So then secondly, since we only have 5 fingers with 26 letters, plus space, enter, caps lock, backspace, and so on, we have to find a way to fit a bunch of symbols in just 5 different combinations. So for this, we use repeated taps. So suppose I tap twice, then it would change the letter from suppose E to F, and so on. So we did this by setting up, so if you see how many taps we do in 400 milliseconds, which might seem like a lot of time for one letter, but it's actually not that much if you're tapping, say, 5 times to get a letter, like, which is like, I don't know, J, for example. And finally, the last thing was combinations, which is for extra characters, because we didn't have that much space. So for example, for backspace, you have to type with 2 different fingers, like that. And yeah, we did this by just checking if both were active at the same time. And yeah, our main problem with this was the code was just very annoying to run because we have multiple different functions running, which Fencer again helped us synthesize and change it back to like 2, I think. But for example, at one point, I think there was just an extra bracket in the code, and that broke the entire system. So it was just really hard to just synthesize it because it was a lot.
Sharon, tell them about the TX pin and the digital sensor.
Oh yeah, also the TX pin, according to Google, it could only sense digital outputs. So we were trying to do this 4 fingers, and then somehow it senses analog outputs, which means it takes multiple different values which works with this. It's not just one value. And yeah, basically Google was wrong in this case, and that's true about that.
Main takeaway is don't trust Google, guys. Demonstrations, go on now.
Yeah, there's no access, but you guys can just come and check it out if you want. The laptop doesn't have access, but there's a screen attached to it, which is very small, so it's very hard to see.
We'll be in the woodworking lab. And now our sign off. So keyboardless, it is just a glove. It's not an attachment. It's a step towards making technology more accessible, more intuitive, and more inclusive. We're not trying to replace the keyboard. We could never. We're just rethinking how we can interact with it so that more people can, and that maybe one day everyone will have a keyboardless in their hand, and we can move towards a gesture-controlled future and not a keyboard-controlled one. Thank you so much.
Okay, who wants to go first?
You.
Example, you want to type something. Okay, wouldn't it be like instead of memorizing all of the tapping and how many taps of one letter, how many taps and all of that, wouldn't it be just much easier to just type on a keyboard with one hand?
Yeah, so 2 things. One, it's actually got a format, so each vowel, which is the most commonly used letters, would be the first one on each finger. So it's easier to learn with that. And also, learning something new, which is even learning a normal keyboard for like smaller kids is very difficult. So this would just be simpler version of that, and it makes life easier. It's much more accessible. Also, it doesn't require you to have a keyboard right here. You can put it anywhere, you can use it anywhere. You see, I'm on my bed, I can use it on my bed, and I will have a the output displayed here.
I know I like to watch Netflix at night, so it'd be much easier to do so.
Can you have like auto words? If I'm going to words like how you have it in a phone, etc., I just suggest the words.
Yeah.
That would be easy, just a suggestion.
So
that
yeah,
would be
that's actually a software on most other platforms rather than the keyboards. But we are working on integrating it into things like Google Docs and Google Sheets, which is something we would try to do, but it took very long and we weren't able to get it working right now. But once you have it linked to that, it would automatically correct. Like how Google Docs has a red line.
I have a question. Since this is for like people who have a disability or like have only one hand, won't it be very inconvenient for them to actually like type like with just taps, like as he said? And secondly, what's the point of the outputs being displayed on that tiny screen? Like because from that tiny screen, where does the output actually go?
Oh no, 2 things. One, output is currently going to CD monitor, and I was working on it to Google Docs. It wasn't happening. And it could also connect to other platforms through APIs. And secondly, the tapping isn't that difficult to learn because just the 3 orders of the alphabet. Yeah, Siddharth wants to explain.
Okay, so the 5 fingers are just the vowels, so A, E, I, O, U. So you could say like, so you know these 4 are A, B, C, D, and E comes here. So it's really easy to memorize because each finger is a vowel. Like the hardest part of this is counting which letter is in which place.
Yeah, wait for it.
And it's not just for people who only have one hand, it's for people who have a preference for gesture control typing or who would like to see it like that. People like to try new things. Anything else?
He's got a question. Yeah.
Sir, at the start of the presentation, you said that if they can't use their hands, what if they can't use their fingers? What are the useful for?
They can use their toes, yeah. So like a quick modification could be made to the glove. You have 5 fingers, you have 5 toes, so you can use your toes, head. You can make 2 gloves, and you have a full keyboard at your hands. 10 keys. How's that?
Also, to add on, you could change the location of the sensors. So, for example, we could do different parts of the palm rather than the fingers. So, if you tap it here or here, it would give you different outputs.
Also, when we got it working last night, I did try it on my foot and it works.
So you said you were designing this for paraplegics, right? So if someone lost their left hand, how exactly do they put on this glove?
Well, all you have to do is slide your hand in, you make a fist, and once you, all you have to like drag it towards you, put it in, and then you're ready to type.
Demonstrate? Yeah.
I felt it to my hand by mistake. I'll do it tomorrow.
Another question. For your next prototype, and I kind of realized this, but that's something I did about 15 years back, is you can just use 2 sensors, and if you got Morse code, you can do the whole alphabet and numbers and all of it, just 2 taps and 2 sensors. And probably it will be more useful for a lot of more folks, because it's kind of easier to do. So think of that, take that forward. Thanks.
Okay guys, I think more questions later. Please take your music ID. You've got to like also Okay, awesome. Sorry? Alright, that was all the presentations for today. Vaibhav, do you want to come to the second part of this presentation? Cool. Alright, so do you want to give them a big round of applause? What do you guys think about it? Just in 7 days? Yeah? Amazing concepts, amazing ideas, all of them are possibilities of kind of going into actually building products and doing more things in this space.
But it wasn't really about the final products. I think we all get that by now, hopefully. It was about the journey. I think what we saw in their presentations as well and what we tried to put together. It wasn't about whether the project is super difficult or easy. It's not about that. It's about what they went through this 1 week, where they learned from each other. How many of you helped a different team? Or somebody from a different team or each other help somebody else during the week?
So busy.
Now, I can ask you this question. How many of you did that? How did you feel while helping other people?
Raise your hands.
No? Okay, the point was to basically learn from building and at the same time going through this journey together, making mistakes, being in a safe space. We call ourselves an asylum for the reason that it's a madhouse for people to come experiment, no matter what the project is, it doesn't matter. That was the basic idea. So hopefully what we've managed to pass on is a mindset or a maker mindset to be able to build more things. Hopefully they'll go back and make many, many more things. And hopefully this is just the beginning. That's one of the reasons why we like to call this day, day 0, at the beginning of the day if somebody noticed that. But back to Richa, she'll tell you about what's next. Thank you.
Okay, just a quick, because a lot of people have been asking us, so I just wanted to kind of put this together at the end of it. So what happens next, right? So all of you, of course, are now L1 level makers. Did you get your passports? Okay. M1 level makers. Everybody has their passports. They'll show you these passports can be used in different parts of the world to access other spaces as well, just like ours. And if we've certified them, they can work with these tools. Most maker spaces should say yes for them to kind of use it as well. All right, so they have a lifelong alumni access to our space. You can keep coming back to Cohort to use our space. So that's one. You can be part of more programs and workshops. We do various kinds of workshops. This is one of our other programs. It's called the SDG School. You guys built something for yourself this time. maybe you can build something from the planet. So this is a much larger contextual program, very interdisciplinary. We do it with a lot of universities, UN agencies. We also have a lot of level up immersions. We're planning for a couple of international immersions next summer, where we're hoping to take all the alumni to some really exciting makerspaces in the world. This maker community is I would say it used to be a subculture. I don't know, now it's becoming mainstream. But when we started back in 2013, nobody knew why a makerspace needs to be there, especially in India. A lot of questions around that, but now there are, every university in the world has a makerspace. If you go to any part of the world, you'll see makerspaces. There are less spaces which are independent, like Makers Asylum. We don't run under the umbrella of any other organization. So we're open to all kinds of people. But makerspaces are all over the world. So it's a pretty large global community of people who understand what we possibly passed on to all of them as well. So next year we're hoping to take them to some of these really cool places. So yeah, if you're up for it, please sign up. You can also be part of the Alumni Maker Mentor Network and come back, just like what Sabir did, to add some more points to your Maker Passport and Maker Journey. Because the more you kind of come back and share, what happens is your skills just improve. I'm hoping that you're kind of, what did you learn this time, Sabir? Something new?
Like, I learned to see problems from like multiple perspectives.
Yeah. So there's always something that you're adding on, right? You can also volunteer and intern with us. We also, apart from all the educational programs that we do, we also have an open research wing where we implement a lot of projects on the ground. That means to say that we do a lot of open research work ourselves. And these are kind of funded by different partners. These are governments, and these are community-led projects. So we definitely call out, and when we need interns and researchers, you guys can all join us as part of these, as well. And what can parents do? We originally started Makers Asylum as an adult-only space, so this is quite new for us actually, to have a lot of children at our space. So, not children, but young adults. I would say it always used to be 18 plus. We actually, I think Anol and Beba were shooed away a lot of young people in the last many years. But in the last 5 years since we moved to Goa, actually we realized that it's so important for passing on this culture that we've built to the next generation, because we feel that this is when the impact in the way that you think happens, the way that you perceive the world out there. So it's very important to pass it on now. So Innovation School has been kind of one of our flagship kind of ways of doing it. But just like all of them, you guys can also pick up making skills. You can do our workshops. Our woodworking workshop is very popular. A lot of people come from across the world to do that. For 6 days, you can build your own furniture, you can do rocketry, you can do, whatever. So if you're somebody who likes it and wants to explore the itch of building with your hands, please come and spend some time in Goa with us. You can be a parent ambassador for also taking this culture forward with us. Over the last 12 years, Makers Asylum has been only word of mouth, honestly. Like, we've not done any, lesser, traditional things to talk about ourselves. It's only about when people meet, they experience the space, they experience the people, they go back and talk to other people, so please do share. I wanted to talk about the Innovation School Kochi. This program, while we started as a small initiative, and we thought that this could be something that we can, build on. From Goa, it now has over 400 plus talents. You guys are part of a much larger family. From 50 plus cities, I don't know this time how many cities, I think we have it on the list. Yeah, so I'm going to talk about 15 countries now. The program in the last 3 years grown to 150 schools. It's become pretty diverse. Originally, a lot of students used to come to us from Bombay because that's where we were earlier. But now it's really diverse in the last 3 years of the program. This summer we had about 77 of them, 24 teams and 5 immersions. So this is the last immersion. As you guys saw, this was the last part of the program. This is Cohort 1. We did a lot of different projects across the board. I don't know if you guys saw these projects, by the way, but these are some of the projects that came out. There's a rescue rover, there's a glove that translates sign language into real-time speech. There's a smart cricket mat that you can use to kind of fix the way that you work. There's WaterWise, which is an automated plant watering system. It's the tennis racket, which is a smart tennis racket. In Cohort 2, they made a drinks mixer robot. They made this really beautiful, it's a sketch pen just here, actually to make art inclusive for blind people. They made this, it's like a beautiful bot that kind of does that. It kind of has braille on it, so you can actually touch and feel art. We also had wearable devices that monitors heart rate. There was a tank that treated a robot that detects plastic waste. There was Kitty inside, similar to what you guys did, the farm bot, but like a different version of it. There was a Cohort 3. These guys made Neuroband, which is a really exciting device that kind of helps you reduce anxiety. There was EcoLens, which was a 3D printed smart lens sunglasses that can help people with hearing loss. So how does it kind of work with that? They had AeroWeight, which is a battery-powered air purifier as well. This was another cohort that we did in Bombay this year. This was the one cohort that we did over there, which was Posture Pulse, which is smart posture corrector. There was Braille Wrap for, again, inclusion and visually impaired folks to kind of like read and scan devices around them. And then there was a metronome, which was a vibrating metronome device that provides, synchronous vibrations and pulses to kind of learn about, music, I guess. But we also do a lot of social impact and inclusion work. So if you are somebody who knows people who could actually fund us, we are a non-profit as well. So we work with a lot of inclusion as well. And of course, all of these guys have come via the other route. There are a lot of people who've come to the program via the inclusion route, and we're looking to kind of raise funds every year to do that. So if you know of someone who would like to support that, please let us know. This program is, of course, while it's a learning program, it's also a life career exploration skill program. A lot of the students have gone to some great universities, and a lot of that story has been part of this whole journey as well. Maker portfolios are becoming a big deal in universities across the world. They really are looking for this kind of uniqueness when it comes to portfolios as well. We also provide a lot of acceleration and other opportunities as part of the community. So this is not the end of what we're doing, obviously, with them. And it's just not for high schoolers. But I want to talk about this last story before I actually stop, is that these guys are part of our first batch. They met as part of the program. Naman's part of the regular IB route by Ambani in Bombay. Great school. Ganesh came via TFI through our foundation and inclusion route. They met in the program. They started a drone delivery startup in Bangalore called Airban. They raised about $2 million just about a couple of months ago. Just same set of age group, 20 years old, kind of doing something like this. Well, this is not the end goal, but this is where you kind of meet like-minded people. You guys have made friends. You don't know, maybe they'll be your co-founders in the future. Who knows, right? So that's the whole point and power of this space and community. And these skills matter in the future because, there's a lot of research around it, there's a lot of science behind it, but I think one of the things that really, kind of for me, I guess for us is important is that it shifts you from being a consumer to a creator, which I think is going to be one of the most important skills in the future. So you're kind of going into that journey, and I think that's why it matters. So we're building the future with all of you. And yeah, thank you so much for listening out. That's about it. I don't have too much to say now. Okay, awesome. Yeah, we can pass it on. So we've got the certificates for the parents. Just because we don't, it's a great souvenir for the whole experience. So we've got the certificates. We pass that around to everyone. You can just give it out with the mentors one by one. Shall we? Can we get the certificates?